Okay, so let me prepare you, mentally prepare you, like turn your brains on. This is going to be the hardest lesson that you probably do this year. It's something that took me forever to really get, even in college when you are working with chemical equations. You're going to realize that this is kind of, it takes a different part of your brain. So please know that this might be one of the lessons that you have to watch a couple times in order to get what we're doing. Plus, we are going to practice this in class, just so you know. So prepare yourselves, because what we're going to be talking about is equations. And when you look at chemical equations, you might be like, what the heck do these mean? They're just a bunch of symbols, because we've talked about the periodic table, right? We've talked about what atoms are. We've talked about what elements are. And then we looked at the periodic table and we saw what the element symbol was, okay? And we talked a little bit about what each of those mean as far as the characteristics, the atomic number, the atomic weight, how many protons, electrons, blah, 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 blah. But now you're going to see those chemical symbols in a different way and what we mean by chemical reactions. We also, to back up even further, we've also talked about chemical reactions versus physical reactions. And a lot of what we're going to talk about now when we talk about equations are chemical reactions where you have products, okay, that join together in order to form reactants, reactants, back up a little bit. You have reactants that form products, the product being the end product, okay? So you guys need to understand a little bit about the chemical equations. So what they do is they show the elements involved in a reaction and how they interact, okay? And you'll see that all in just a chemical reaction. So take a look at this picture. Okay, we know the lovely, molecule water, okay? We drink it often, hopefully a lot during the day. And it's made up of two different elements, hydrogen and oxygen, okay? So basically, hydrogen and oxygen molecules are going to combine to form water. So you have these two different elements coming together to form water. They have different types of bonds, which we don't need to go into, necessarily. But when I talk about what the equations mean, remember, it does talk about how they interact. How do these two elements interact to form water? Well, there are specific bonds, actually called polar bonds, but you'll learn that probably next year in lovely high school. But know that a reaction can actually show those different things, okay? So it's going to show the elements involved, it's going to show the end product, and it's going to show how they interact, okay? Now, one thing you guys have to know are the products and the reactants. Anytime, this is basically always how you're going to view a chemical equation. Sorry, I lost my train of thought for some odd reason. So you're always going to have products and reactants. Reactants are always going to be on the left side here of this arrow. And sometimes you might see this arrow going both directions, but in this case, this arrow is going this direction, so your reactants are on the left side, and the arrow is pointing towards what's going to happen. So this is going to be your product, okay? So it's very important for you guys to understand the reactants and the products and basically where those lie in the equation. Now, if for some reason, now you're never going to see it, but if for some reason the arrow was turned around and it was going the opposite direction and this arrow was pointing this way, then your reactants would actually be on this side and these would be your products, okay? So say for instance, I can't draw on the whiteboard, I need to learn how to do that, by the way, but basically if I were to draw another arrow going the opposite way right under that, that means that the reaction can go both ways, okay? But in this particular example, you can see that everything on the left here, Na, sodium, and Cl, chlorine, or what we call chlorine, makes sodium chloride, which is table salt. Okay, this is our product. These are our reactants. They join together to form table salt. Okay, so absolutely you have to know which are your products and which are your reactants. It's a pretty easy thing that the arrow tells you a whole lot about which direction that equation is going. So ultimately, whatever's on the other side of the arrow and which direction it's pointing are going to be your products, your end products. Now, the most difficult part about this is the balancing of these reactions. So you have to ask whether or not the equation is balanced. Okay? Is that equation balanced or not? Because if it's not, then we are talking about going against some of the laws that maybe you guys have heard of before. That basically matter is never created or destroyed, but it's only changed. So say for instance, if we start off with one atom of oxygen on the reactant side, And then all of a sudden on the product side, where you have that arrow pointing in this direction, you have 2 atoms of oxygen. Where did that extra atom of oxygen come from? Well, did it just appear? Did some magician go poof and there's another molecule of oxygen? That's not possible, okay? So you have to have a balanced equation because you have to have the same number of oxygen atoms on one side of the reaction as you do on the other. So the same number of reactants is going to yield the same number of products, okay? It's very important to understand that. Sometimes you'll see unbalanced equations, but you have to know that that's not what really happens. We don't just have these atoms appear and disappear, okay? So the left side must equal the right side, and the types and amounts of elements on the left side will always be equal to the right. So we're going to do some quick examples, but I promise we're actually going to go over this a lot more in class. So I want to make sure that you guys have kind of a basic understanding as you watch this mini lesson, and then we'll actually do some problems in class so that you guys have a really good understanding. Now just so you guys know, again, this is a really tough concept. You will be studying this throughout the rest of your high school. So if you don't get it to its nth degree right now, you're going to keep going over it. I want to introduce this to you guys if you haven't seen this before, and try to let it kind of sink into those lovely brains. Okay, so let's look at this. Here's a chemical equation. We have sodium and chlorine. This is one we talked about before. Sodium, Na, plus Cl2, which is how chlorine exists. It exists as 2 atoms, okay? That's just the way it is. You just have to accept that, okay? So Na plus Cl2 yields 2NaCl, okay? You have to know if you didn't have that 2 there, if I X that 2 out, how many atoms would you have of chlorine over here? You'd only have 1, right? Well, you have 2 over here. So you put a big coefficient 2 here, okay? And basically, going back to math, you're going to multiply that 2 to the sodium and to the chlorine, okay? Oh, but that's not balanced now. Because now you have 2 sodiums, but how many do you have over here? So you'd actually add a 2 in front of this Na to be completely balanced, okay? So do you understand that you have to have the same amount on one side as you have on the other? So again, this may not make sense to you right now, but I promise when we start doing some in class it will. Plus, I would love to be able to write on this PowerPoint right now, but unfortunately as I record I cannot do that. So just know that you have to balance this out. So 2 NaCl, you'd actually have to put a 2 in front of this Na, and then that's totally balanced. You'd have 2 Nas over here, 2 Nas over here, 2 chlorines, 2 chlorines. Okay, remember that big coefficient 2 is like you are multiplying to everything in front or everything behind it. So 2 Nas and 2 Cls. And then copper sulfate, Cu plus S gives you CuS. If you check that out, that's completely balanced, so you don't have to add anything to that. There's 1 Cu here, 1 Cu there, 1 S, 1 S. Okay, kind of hard to understand, but here's another one. You have CH4 plus 2O2 yields CO2 plus 2H2O. Okay. Now again, these little 2's, these big 2's here, did not exist until it was balanced. Okay, so you had to add those because remember, we have a CO2 here, so that would be 2 oxygens and 1 carbon. If there's no number next to that letter, that is an understood 1 atom. Okay, so you have to understand that. 1 atom of carbon, 2 atoms of oxygen. Before that 2 was there, you had 2 hydrogens and 1 oxygen, and it's not balanced. You have to add those 2's in order to balance it. And here's how they check it. So they look at, on this side, how many carbons? Well, there's 1 here. How many hydrogens? 4. How many oxygens? Well, there's 2 coefficient times 2, so that's where they get 4 oxygens, okay? Again, that may be kind of hard to understand, but you'll get that. Over here, you have 1 carbon. You have 4 hydrogens, sorry, so 2 times 2, 4 hydrogens. And then you have 4 oxygens. So you have 2 over here, and then 2 times this one gives you 2. So 2 plus 2 is 4. So you can see that those are now balanced, okay? So kind of a crazy, like, oh, I don't get it. Let's watch this video real quick and see if this helps a little bit. Ta-da!
How to balance chemical equations. According to the rules of chemistry, matter must be conserved in chemical reactions. When you balance a chemical equation, you account for all of the matter in the reaction. You will need an unbalanced chemical equation, paper, and a pencil. Step 1. Determine how many atoms of each type are on each side of the equation. List the numbers of each atom for the left side and for the right side. Step 2. Find an element that is in only one compound on the left side and in only one on the right side of the equation. Start with an atom other than oxygen or hydrogen. Oxygen and hydrogen atoms are usually in more than one compound on either side of the equation, so they are best left to last. Step 3. Multiply the chemical compound on the side that has less atoms of that type by the number required to achieve the same value on the other side. Step 4. Select another element or compound that is not balanced and balance it. Step 5. Repeat this process until the equation is completely balanced. Step 6. Eliminate any fractions in the balanced equation by multiplying through by the denominator of the fraction. Did you know Parisian scientist Jean Beguin wrote the first chemistry textbook in 1610?
Alright, so there you go. There's kind of a quick video. Now that was really fast and maybe over your head, but feel free to pause that and rewind and go through that again and notice what happens in each of those steps. But again, we'll practice that together. So we're going to practice this real quick, and then I'm going to take a break and come back and talk to you guys about photosynthesis. Alright, so practicing water plus carbon dioxide yields glucose and oxygen. I hope this may start to sound familiar, this particular equation. So it looks like you have to write that out actually. So you have water, H2O, plus carbon dioxide is CO2, yields glucose, which you'll get to know this, C6H12O6, and plus oxygen. Hopefully you guys recognize this, maybe from 7th grade, 6th grade, possibly. This equation is very important. This is the equation of photosynthesis, okay? So again, H2O plus CO2, and then it yields, okay, your arrow is telling you that it's going to give you products of glucose, C6H12O6, plus oxygen. Obviously, you have to have that in the presence of sunlight. But this is not balanced, okay? If you look, there's 2 hydrogens over here and 12 over here. That's clearly not balanced, okay? So we know right away that's not balanced. You have to start working through this. So in order to do that, you start to go through and figure out, how can I get 12 hydrogens? Well, let's put a 6 there. 6 times 2 is 12. Okay, then you have 6 oxygens here. Then you have to add another 6 over here because you have to balance everything out. Now this is a little bit harder of an equation. We'll start off easy, I promise. But in order to balance it out, you have to put these big coefficients. You're never going to put these little subscripts, okay? Those are only in there if they are already a part of that. So you'll never add these little subscripts. You'll only be adding these larger number of the coefficients, okay? So we'll go over that more in class. Please just let that kind of slowly sink in, okay? So that equation was for, hopefully you guys remember, good old photosynthesis. So we're going to take a break and we'll come back and talk a little bit more about photosynthesis in part 2. Join me right away.